Humanity has always looked toward the stars searching for one answer. Are we alone? Now, for the first time in history, that question may no longer belong only to science fiction. The James Webb Space Telescope, the most powerful space telescope ever built, has captured something extraordinary near the closest known world beyond our solar system. Mysterious glows. Faint pulses of light emerging from a distant planet called Proxima Centauri B, located just over 4 light-years away from Earth. At first glance, the signals seemed impossible. The light appeared structured, rhythmic, persistent. Unlike natural events such as volcanic eruptions or auroras, which scatter energy chaotically, these emissions showed repeating patterns that appeared strangely organized. And that is what captured the attention of astronomers around the world. Could this be the first sign of artificial light from an alien civilization? Proxima B orbits Proxima Centauri, the closest star to our Sun and part of the famous Alpha Centauri system. The planet exists inside the habitable zone, the region around a star where temperatures could allow liquid water to exist. For years, scientists considered Proxima B one of the most promising locations in the search for extraterrestrial life. But nobody expected evidence like this. What makes the discovery even more fascinating is the nature of the planet itself. Astronomers believe Proxima B is tidally locked. One side permanently faces its star in endless daylight, while the opposite side remains trapped in eternal darkness. If intelligent life evolved there, civilizations may have adapted by building artificial illumination across the dark hemisphere. And according to Webb's observations, faint infrared emissions appear to be coming precisely from that permanently dark region. Not random flashes, but steady glows that fluctuate in ways eerily similar to city lights seen from orbit around Earth. Some scientists remain cautious but intrigued. Because whatever these signals are, they demand explanation. Understanding the mystery begins with the star itself. Red dwarf stars like Proxima Centauri are smaller and cooler than our Sun, but far more violent. They frequently release powerful solar flares capable of stripping atmospheres from nearby planets. Under normal conditions, such an environment would seem hostile to life. But Proxima B may defy those expectations. If the planet possesses a dense atmosphere strong enough to block harmful radiation, it could potentially support oceans, weather systems, or even advanced civilizations hidden beneath clouds or underground cities. To uncover the truth, scientists analyzed the chemistry of the planet's atmosphere. As starlight passes through atmospheric gases, it carries chemical fingerprints that reveal what exists there. Using infrared observations, Webb can detect compounds such as water vapor, methane, and carbon dioxide. And what researchers found on Proxima B raised even more questions. The atmosphere appears to contain unusual chemical ratios, particularly high methane levels without corresponding amounts of carbon monoxide. On Earth, methane is often linked to living organisms or industrial activity. That doesn't prove alien life exists. But it creates a mystery scientists cannot easily ignore. Because chemistry like this should not exist so easily without some kind of active process constantly renewing it. And if those processes are not geological, then what are they? As scientists continued studying Proxima Centauri B, the mystery deepened. The strange light patterns did not behave like ordinary planetary activity. Natural events are usually chaotic. Volcanoes erupt unpredictably. Thermal vents fluctuate randomly. Storms scatter energy unevenly across a planet's surface. But these emissions appeared organized, symmetrical, repeating in intervals almost reminiscent of energy grids on Earth. That observation led to an extraordinary possibility. What if the lights are not simply illumination? What if they are signals? Some researchers believe advanced civilizations may communicate using directed light instead of radio waves. Powerful lasers or modulated infrared pulses could travel enormous distances through space far more efficiently than traditional radio transmissions. For decades, the search for extraterrestrial intelligence focused mainly on radio signals. But telescopes like the James Webb Space Telescope are expanding that search into entirely new wavelengths. Infrared light is especially important because it can pass through cosmic dust and planetary atmospheres more effectively than visible light. And if an advanced civilization wanted to remain hidden while still communicating across the stars, infrared technology would make perfect sense. There are other possibilities as well. The glows may come from massive engineering projects orbiting the planet. Perhaps giant mirrors reflecting sunlight onto the dark side. Perhaps enormous solar collectors harvesting energy from the star. Or maybe vast orbital structures surrounding the planet itself. If life exists on Proxima B, it would likely face extreme environmental conditions. The constant radiation from its red dwarf star could force civilizations to adapt in extraordinary ways. Underground cities. Protective domes. Artificial climates. Technology on a planetary scale. Of course, scientists must also consider natural explanations. Some astronomers suggest the lights could originate from geological activity or atmospheric interactions not yet fully understood. But the consistency of the signals continues to challenge those ideas. And detecting these emissions at all is an astonishing achievement. Stars like Proxima Centauri outshine their planets by billions of times, making direct observation incredibly difficult. The James Webb Space Telescope succeeded largely because of advanced starlight blocking technology called a coronagraph, allowing faint planetary light to emerge from the overwhelming brightness of the host star. Future missions may push even further. NASA's planned observatories will use even more advanced systems capable of directly imaging distant Earth-like worlds. One proposed concept, known as the starshade, involves a giant flower-shaped spacecraft flying thousands of kilometers ahead of a telescope, blocking starlight so planets can be seen clearly. Meanwhile, powerful ground-based observatories like the extremely large telescope currently under construction in Chile will soon study exoplanets in unprecedented detail. These instruments may finally reveal whether the mysterious glows on Proxima B are artificial, or simply phenomena humanity has never encountered before. But if the lights truly are signs of intelligent life, the implications are enormous. It would mean humanity is not alone. An advanced civilization could exist around the nearest star system to Earth, only a few light-years away. Perhaps watching the universe just as we do. Perhaps asking the same questions. What would their world look like? Would they be peaceful explorers? Survivors of a dangerous star system? A civilization millions of years older than humanity? Questions like these blur the line between science and philosophy. Yet this is the power of discoveries like this. They challenge our assumptions. They force us to rethink humanity's place in the cosmos. Skeptics continue urging caution, and science demands it. More observations are needed. More data must be collected. Every possibility must be tested carefully. But regardless of what these lights ultimately turn out to be, something fundamental has already changed. The universe no longer feels silent. Somewhere beyond Earth, on a dark world orbiting a distant red star, strange lights flicker against the cosmic night. And if those lights truly belong to another civilization, then perhaps, for the first time in human history, someone out there has already whispered across the stars, "We are here."